Hello student, this is Latif sir. Today I'll discuss about Icse class 10th chemistry. The topic is the periodic table, periodic properties and variation in periodic properties. This is my last video on this topic. Today I'll discuss about some important points on this chapter, uh, like diagonal relationship. I have already discussed about different types of different type of periodic properties, electronegativity, electron affinity, ionization energy. You have to read all these terms, definition, and their variation along period, along groups. Okay, because these are important, very important. So let's see what is the diagonal relationship. In the periodic table, it is generally found that in periodic table there are some elements of second period shows the similarity or resemble in properties with with some elements in the next group of the third period. Okay, the elements of second period show resemblance in properties with the elements of next group of the third period due to very less electronegativity difference. This is this leads to a diagonal relationship. Diagonal in one word, diagonal relationship means similar property diagonally. Okay. For example, you can see here in the figure group 1 to 1 to 13 and 14 and period 2 and 3 written here, and lithium shows diagonal relationship with magnesium. Beryllium shows diagonal relationship with aluminum, and boron with silicon. These are example of diagonal relationship. And the element, and these elements are called bridge element. You have to remember bridge element: lithium and magnesium, beryllium and aluminum, boron and silicon, because they show similar properties due to less electronegativity difference. Now again one note: get at the value of electron affinity. Electron affinity, easier it to gain electrons. Electron affinity means the energy change to accept uh, change due to addition of one electron to an atom, gaseous isolated atom, is called electron affinity. So get at the value of electron affinity, easier it to gain electrons and more non-metallic character, more electronegative and more oxidizing is the element. So get at the value of electron affinity, easier to it to gain electrons and more non-metallic character, or more electronegative or more oxidizing is the element. Metals generally lose electrons while non-metals accept electron. Metals lose electrons, they have less ionization energy, IE or ionization potential, less electron affinity EA, less electronegativity EN, and have large amount atomic radii as compared to non-metals. And non-metals are just opposite. They accept electrons, they have high ionization potential, they have high electronegativity, high electron affinity, and small atomic radii. Now, some term you have already learned in lower classes: atomic number. Atomic number is the number of protons in the nucleus of an element. The number of atomic number of an element is equal to the number of protons in the nucleus. In one word, number of protons in the nucleus. Atomic number is the unique property of an element because no two elements have the same atomic number. You have to remember it. Among atomic number, atomic mass, Newton number. Okay, so among these, atomic number is the unique property of an element because no two elements have the same atomic number. Atomic number generally represented uh, by the by Z. Atomic number represented by Z. Atomic number is equal to number of protons, and we know that number of protons in the nucleus is equal to number of electrons in the outermost orbits. Okay, so atomic number is equal to number of protons is equal to number of electrons, and atomic number distinguishes an element from the other element because no two elements have the same atomic number. Atomic number gives the electronic configuration of element. For example, an element with atomic number 13. What will be the electronic configuration? 13 means 13 proton, 13 electrons are revolving around the nucleus. So the electronic configuration will be 283. 2 in first cell, K cell, 8 in L cell, K, L, and M in M cell. There are 3 electrons. Now, atomic number helps us in finding the position of an element in the periodic table. Atomic number is helps us in finding the position of an element in the periodic table. For example, an element with atomic number 17. So, atomic electron configuration will be 287. 2 in K cell, L in L cell 8 electrons, and in M cell 7 electrons. Total 17 electrons. So total number of cell is 3 KLM, that is 3 number total number of number of cell represent the number of period. So third period element, and number of valence electron is 7. So it group number is 7A, or you can also write 10 plus 7, that is 17. Group number is 17, or in Roman word 7A group number. This is because it has 3 energy cell and 7 electrons in the outermost cell, and the number of electrons in outermost cell represent the number of group number. Okay. Now we have here up to 20 first 20 element, atomic number of first 20 element given. You have to remember because this is important. Huh. For example, atomic number of hydrogen is 1, atomic number of helium 2, atomic number of lithium 3, up to calcium, that is 20 atomic number. You have to remember, just take a screenshot and read and memorize the sequence sequentially. Okay. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, like this. Okay. So, and their electronic configuration not given here. You can write also atomic number, mass number, and number of newtons given. Right. What is mass number? Mass number is the number of protons and newtons in the nucleus. The mass number of an element is the sum of number of protons and electrons in the nucleus of an atom of that element. That that is, mass number A is equal to number of protons P plus number of Newton N. It is generally found that for lighter elements, for that is for hydrogen, helium, for this element, those elements which have an even number of protons, those elements which have even number of protons, they have they have mass number just twice of their atomic number. So a close look at the electronic configuration of lighter element reveals that those elements which have an even number of protons, for example, atomic number of uh, helium 2H4 He4, for carbon 6C12, etc., have their mass number twice of atomic number, except 4Be9, 18, argon 14, 40. Okay. And elements which have an odd number of protons, this is not any rules. This is generally found for elements which have an odd number of protons, like lithium 3 Lic, boron 5b11, fluorine 9 19, sodium 11 23, etc. They have mass number twice of atomic number plus 1. So mass number A is equal to 2Z plus 1. There is some exceptions also. For example, 7n14. That is, in case of nitrogen, atomic number 7, mass number is just twice of 7, 14. But according to this rule, mass number should be 15. But that's why nitrogen is not following. This rule is not valid for nitrogen and hydrogen 1H1. Okay. And some notes: elements with Newton pi proton ratio, N by P ratio around 1 are stable. That example, light metals like sodium, potassium, calcium, etc. are stable. And elements with N by P ratio is greater than 1.5 or equal to 1.5 are radioactive. That is, they emit radiation. Elements with N pi p Newton by proton ratio 1.5 and above are radioactive. That is, they emit radiation. They are unstable element. They are generally heavier metals like uranium, plutonium, neptunium. These elements are radioactive because they have Newton by proton ratio greater than 1.5. And here the comparison of alkali metal and halogen. Alkali metals means group 1 element: lithium, sodium, potassium, rubidium, cesium, francium. Except hydrogen in group 1 element, group 1, lithium, sodium, potassium, rubidium, cesium and francium are group alkali metals, and groups halogens are group 17 elements, that is fluorine, chlorine, bromine, iodine and astatine. So let's see their comparison, their similarity, dissimilarity. Okay, first, elements. I have already told which elements in group in case of alkali metal and in case of halogen. You can see here again. Now occurrence. Both alkali metals and halogens are reactive. That's why both they are present in combined state, okay, in nature. So alkali metals occurrence combined state due to their reactive nature. Halogen also combined state as salt. Halogen form present in combined state as salt due to their reactive nature. Both are reactive. So this is similarity between alkali metal and halogens. Second, physical state. Alkali metals are metals, therefore they have shining white solid metal. They are shining white solid metals, soft and can be cut with a knife. Lithium is the hardest. Generally, alkali metals are metals. These metals, shining white metals, and they are soft and can be cut with knife. And lithium is the hardest among them. And they are shiny when freshly. Uh, they are shiny when freshly cut, but soon become dull as they react with air. They are shiny when freshly cut, but soon become dull as they react with air. So this is a physical state of alkali metal. Now physical state of halogen. Halogen non-metals. Halogens are non-metals. Diatomic, that is F2Cl2Br2. So diatomic in gaseous state. Halogens, and among them fluorine is very reactive poisonous yellow gas. Fluorine is very reactive poisonous yellow gas. Chlorine poisonous yellow green gas. Bromine poisonous red brown volatile liquid. Bromine is a non-metal, although it is non-metal, a non-metal liquid. Bromine poisonous red brown volatile liquid. And iodine dark gray crystalline solid, although it is non-metal iodine, but it is a dark gray crystalline solid. Okay, next physical property, valence electron. Alkali metals possess one valence electron and therefore they show similar properties. All alkali metals possess one valence electron and therefore they show similar properties. Similarly, valence electron of halogen, you can see the halogens have 7 valence electron each, and therefore they show similar properties. Now conductance. Now conductance. Alkali metals good conductor of electricity because they are metal, but halogens are non-conductor of electricity. Nature. Alkali metals. Nature of alkali metals, they are highly reactive electropositive metal. Highly reactive electropositive metal. Metallic character increases from lithium to francium. You have to remember, metallic character of group 1 element increases from lithium to francium. This is the group 1 elements nature. And group 17 elements nature. they are also highly reactive, but they are electronegative, while group 1 elements are electropositive and group 17 halogens are electronegative. Group 1 elements are metal while halogens are non-metal. Group 1 elements are metallic but group 17 elements are non-metallic. And non-metallic character decreases from fluorine to iodine. That is, metallic character increases from fluorine to iodine. Okay, just opposite. Non-metallic character decreases from fluorine to iodine. That is down the group. Now, melting and boiling point. As group 1 elements are metal, they have a high melting point and boiling point, and melting and boiling point decreases down the group in case of alkali metals. And in case of halogens, we know that down the group atomic number increases, atomic size increases, mass number increases, atomic mass increases. Therefore, down the group in case of halogens, down the group boiling point and melting point increases down the group. Now atomic size, I have already told, in case of group 1 element, they have largest atomic size in their period, except inert gases. Atomic size, alkali metals have largest atomic size in their period, and the atomic size further increases down the group, while atomic size of halogen, they have smallest atomic size in their period and atomic size increases down the group. Halogens have smallest atomic size in their period and atomic size increases down the group, while atomic size of alkali metals have largest atomic size in their period. Okay, and atomic size increases down the group. Ionization energy, group 1 element alkali metals are metal, that's why they have lowest ionization energy in their period, and uh, down the group it decreases. Atomic ionization energy down the group decreases for alkali metals, and they have low ionization for energy. And for group 70 element, that is halogen, they have high ionization energy, that lower than noble gas, it should be mentioned. They have high in ionization energy lower than noble gas in their period. Electron affinity, same. Alkali metals have low electron affinity value, which further decreases down the group, and halogens have high electron affinity value. They too decreases down the group. These are differences between alkali metals and halogen. And first, some the points at the beginning, they are resemble property between halogen and alkali metals, and now these are differences between alkali metals and halogens. Reactivity, they are both reactive. Alkali metals are reactive metals, and reactivity further increases down the group. And in case of halogen, they are reactive non-metal and reactivity decreases down the group, while in case of alkali metal, reactivity increases down the group. Reaction with water and acid, alkali metals react vigorously with water and acid, liberating hydrogen gas, and reactivity further increases down the group. Vigorously react with water and acid to liberate hydrogen gas, and reactivity further increases down the group. While uh, halogens generally do not react with dilute acid and water. Reducing character. As the alkali metals are metal, they easily lose their electrons. So there's a strong reducing agent because they lose electrons to complete their octet. While halogens are non-metal, they easily accept electrons. That's why they are strong oxidizing agent and they accept electron to complete their octet. And last, compound formation. Alkali metals form electrovalent compound with non-metals, for example NaCl, KBr. So alkali metals form electrovalent compound with non-metals, and halogens form covalent compound with hydrogen and with other non-metals. For example, HBr, HCl, HI. These are covalent compound. So these are here comparison between alkali metals and halogens. You can see. And last, some physical property, periodic properties I have already told, and how they varies along period and along group. Now again, this is a summary of the this property, variation of this property. Number of valence electron across the period increases. First, left to right first increases, then decreases, but down the group valency remains same. Atomic size across the period left to right decreases, but down the group atomic size increases. Ionization energy left to right across the period increases, and down the group ionization energy decreases. Metallic character left to right across the period decreases, but down the group increases metallic character. Non-metallic character just opposite, across the period left to right non-metallic character increases, but down the group decreases. Huh. Electron affinity left to right increases, but down the group decreases. Electronegativity left to right, that is across the period, increases, but down the group decreases. Okay, so basic nature of oxide left to right decreases, and up to bottom, that is down the group, increases, just opposite. And melting point increases from group 1 to group 4, and then decreases for across the period, and down the group 1 and 2 decreases, group 3 and 4 decreases, and group 5 to 7 increases. Hmm. Boiling point oxidizing nature left to right increases across the period, and down a group oxidizing nature decreases. Reducing nature across the period reducing nature decreases, and down the group reducing nature increases. So these are physical property. I have already told the summary of the physical properties, how they change. Thank you. This is the last video on the on this topic.